Similar triangles. We're going to look at two triangles that are similar to one another and see what their characteristics are. The first thing we're going to notice is that they have the same shape and angle measurements are exactly the same. So obviously, these are two triangles, exact same shape, and let's look at their angle measurements. Let's look at the angles that correspond with one another. Angle P corresponds with angle D, and they're both 70 degrees. Angle Q corresponds with angle E, and they're both 80. And angle R, 30 degrees, corresponds with angle X, which is also 30 degrees. The next thing is that the side lengths are proportionate. They're not equal because clearly one is larger than the other. But proportionate is very important because if you look at this segment, PQ, it's 3. The corresponding segment on the other triangle is DE, which is 6. If you multiply 2 times 3, you get 6. Let's look at QR. It's 4. The corresponding segment would be EX, which is 8. And we know 4 times 2 is 8. And then the final segment, PR, is 5. If we multiply 5 times 2, we get 10, which is the corresponding segment on the other triangle. So we know that these are similar triangles because the angle measurements are congruent, the side lengths are proportionate. So let's just watch this example. Here's triangle ABC and triangle DEF. We know that angle A is congruent to angle D. We know that angle B is congruent to angle E. And finally, we know that angle C is congruent to angle F. And because of all that, we can say that triangle ABC is similar, that's the similar symbol, is similar to triangle DEF because, and this is how you're going to be able to prove your answers, because the corresponding angles are congruent. And if you look, the corresponding angles, all of these showed that they were congruent. So if that's the case, then we can say that this triangle is similar. Here's example 1 we're going to put in our notes. Are the triangles similar is our question. First thing we need to do is draw the triangles and label them. And then we're going to be given these measurements. Because we already learned that the triangle has to have a sum, the angles have to add up to 180 degrees, we know what the measurements are for the missing angles. We know that this one has to be 50 and this one has to be 30. And there's a couple ways we can go about doing that. You can obviously add 100 plus 30 and get 130 and know that we still need the 50 and do the same thing on the other triangle. Or you can find the corresponding angles. Q corresponds with M. They're both 100 degrees. R corresponds with N. We know it doesn't correspond with L because it's not the same measurement. So we know this has to be 30 degrees. So that's another way we can fill in our angle measurements. So now looking at these triangles, the corresponding angles are congruent to one another, so we can determine that they are similar triangles. So we're going to write our answer. Triangle PQR is similar to triangle LMN because corresponding angles are congruent. And that's going to be your final statement to determine that these triangles are similar. So this is a yes. Are the triangles similar? Yes. And we have a statement to prove it. Here's example 2. Are these triangles similar? So let's figure out what we need to determine the missing angles because I'm not really sure if this is going to be congruent or not. So I'm going to add 65 plus 50 to determine what my missing angle is going to have to equal. Once I do that, I determine that that angle measurement has to be 65 because I'm going to do 65 plus 50 plus x equals 180. And when I solve that, I determine that x equals 65. I can go ahead and look at the other triangle and know that it is not going to be congruent because I already have angles that don't match up with measurement. But I can still determine angle Q by taking 50 plus 70 plus x equals 180 and solving it to get my answer. And that would equal 60 degrees. So we know that these are not going to be similar triangles because of those angle measurements. So our answer, triangle MNO, is not similar to triangle QRP because corresponding angles are not congruent. So that's going to be our answer if it's a no. That's what we'll fill in to write a statement determining if these two triangles are similar. Let's look at example 3. This one's asking for something different. The triangles are similar. It's telling us ahead of time that they are similar. We have to solve for x and find the measurement for angle U. So we're going to have two answers to determine, to finalize this question. So the first thing I'm going to do is I'm going to figure out, in just a second, I'm going to figure out which angles are corresponding because it's telling me they are similar. This one looks like the right angle. It may or may not be, but it looks like one. I can't determine that it is because it doesn't have the little right angle square in it. But I can look at the other triangle, XYZ, and I know that this is the one that corresponds with it. So therefore, I can fill in the other measurements because I know one of them has to equal 59 and the other one has to equal 34 because they are similar. We're told that in the beginning of the example. So here's those measurements. Because I've already learned that the triangle has to add up, the angles have to add up to 180 degrees, I can set up my equation with triangle TUS. So I have this measurement plus this measurement plus this measurement equals 180 degrees. And that's the equation I've set up right there. Then I'm going to go ahead and solve that equation. I'm first going to see that 2x doesn't have any friends on this side, but I can combine 21 plus 34 plus 59. And that's going to equal 114. So my next line would have 2x plus 114 equals 180. Now I have a basic two-step equation, so I'm going to subtract 114 from both sides, and I have 2x equals 66. Continuing now, I have a one-step equation. I'm going to divide both sides by 2, and x equals 33. Well, that's not one of my angle measurements. That's simply what x looks like. So let me change the color. That's not what x looks like. That's what x equals. So now I can take this equation, this expression, and substitute in my 33. So if I'm going to substitute it in, I have 2 times 33 plus 21. 2 times 33 is 66. Bring down the plus 21. And when you add 66 plus 21, you get 87. So I know that the missing angle measurement, angle U, equals 27. So angle U equals 27. Now I'm going to check my directions to see if I've solved everything. Solve for x. I got it. And the measurement of angle U. I got it. So I know I've answered everything on this picture. Here's example 4. It looks a little bit different because the two triangles are combined together. And I'm reading the directions. The triangles are similar. Find the measurement for angle A. So we're going to need one boxed answer. I'm going to go ahead and identify angle A so I know the final answer needs to be what that measurement is right there. So I need to look. It's telling me they are similar, so I need to find what matches each other in the image. Well, I know that Angle A is the same for both triangles. I know that angle C right here is equivalent to angle E. Those equal each other. Then I also know that angle B is going to be the same as angle D. So I'm going to go ahead and fill in that angle D has to equal 60 degrees. Now, you probably already know what all the angle measurements are now, just looking at the triangle, but we can't be sure. So let's go ahead and start to solve to find the other angle measurements. Because I know angle C and angle E are congruent, I can set them equal to each other to find what x equals. So I'm going to do that right here. I have 3x minus 21 equals 2x plus 6. Now I'm going to start moving things around using the inverse operations to be able to find my answer. Let's draw a line down the equal sign. I have choices here. I can move the 3x, I can move the minus 21, I can move the 2x, I can move the plus 6. I like to get all of the x variables on the same side, and I like them on the first side. So I'm going to choose to move the 2x to get it to the first side. And I see that 2x is positive 2x, so to get it to the other side, the inverse operation is minus 2x. I'm going to minus 2x on both sides. Then I'm going to be able to cancel that out. And 3x minus 2x is 1x. I don't need the 1x, I just need the x. So I bring everything down. So I have x minus 21 equals 6. Again, this isn't the exact and only way you can solve this equation. You can solve it many ways. Just make sure you get the same answer by doing it correctly. Now I have x minus 21 is 6, and I have a one-step equation now. So I'm going to notice that I have more things on the first side than I do on the second side. I have more terms. The first side I have 2 terms. Second side I have 1 term. So I need to get rid of something on the side that has the most terms. And I see that I need to get rid of the minus 21. The inverse operation of minus 21 is plus 21. So I can add 21 to both sides, and this cancels, and I'm left with x by itself on the first side. So I know that x equals, and if I add 6 plus 21, I get x equals 27. So that's not my final answer. I guess I shouldn't even have a box around it. But I have x equals 27 because I need that to determine my angle measurements. So because I'm looking for angle A, I can choose to substitute the x into this expression or this expression. And I'm going to choose the 3x minus 21. So I'm going to substitute 27 in place of this x. And so that looks like 3 times 27 minus 21. If I multiply 3 times 27, I get 81. And then I bring down the minus 21. And now I can solve this simple math problem. 81 minus 21 equals 60. So I know angle C has to equal 60 degrees. And because I know angle C, I know angle E will also equal 60 degrees. Now I really know what angle A equals, and I can probably do it in my head. But because I want to show my work and make sure I'm doing this accurately, I'm going to write out the equation. I know that this angle plus this angle plus this angle has to add up to 180 degrees. And of course, I could also use the smaller triangle, 60 plus 60 plus angle A equals 180 degrees. But either way, I have the same numbers. And then I combine the 60s. So A plus 120 equals 180. And once I solve the one-step equation, angle A equals 60 degrees. So angle A equals 60 degrees. And I have my final answer. Now we can do the similar triangles homework.